Hello, everybody. This is the first lecture in linear algebra, and the title of this lecture is System of Linear Equations, Part 1. This part corresponds to section 1.1 of our text, and the text we adopted here is linear algebra and its applications, published by Lay and Lay in McDonald. And in this very first lecture, we just talk about why do we need to learn linear algebra and what we're going to learn linear algebra. And basically some introduction. And you can just sit back and relax and enjoy. So the first question, what do we study in linear algebra? Linear algebra is to study a system of linear equations via matrix and vector. So there are two important keywords, matrix and vector. And the second question, why do we study linear algebra? Because they have many applications in many different areas, like machine learning, economics, finance, statistics, image processing. And I also recommend everybody to watch a YouTube video provided here. All right, to this end, you may ask a question, what is matrix? How do you define matrix and vector? Now you can Google search the matrix and you probably get such a picture given here, a box with full of numbers. Well, is it the matrix we wanted in the text? The answer is yes. In our textbook, the matrix is defined as a rectangular box of numbers. So for example, 2 by 3 matrix, here A, as an example, 2 by 3 matrix. So 2 stands for row, 3 stands for the number of columns. And there are two other examples. B sub 1 is 2 by 1 matrix. B sub 2 is 1 by 2 matrix. And we say that if a matrix has only one row or one column, then it is a vector. So vector is a special kind of matrix. Next, we're going to talk about one application in image processing. We mentioned that there are many applications, and this is one of the simple enough application we can explain in the first course of linear algebra. So imagine that one day you went to WPI campus and took a picture, which is on the left-hand side. And now you used your computer skill, programming skill, transform this picture to what you saw on the right-hand side. Now we won't understand how you implement this transformation. Is it something related to linear algebra? The answer is yes. First of all, we need to understand that a picture consists of millions of pixels. And what transformation does is moving all those pixels from first picture to a new pixel in the second picture. So for example, this corner goes to this corner, and this corner goes to this corner. And not only corners, you need to move all the pixels inside this picture to corresponding new coordinate or new pixel. Then what you need to do is tell computer how to move these pixels. This page tells us more details about this transformation. The transformation maps each coordinate vector of the first picture to another coordinate vector of the second picture by this given formula. So let's take a point from first picture and illustrate this formula. So for example, I took 100, 100 from the first picture, so this point. Look at its horizontal axis, the coordinate value is 100, and vertical coordinate value is 100, so this corner. Then if you take this 100, 100 from the first picture, then it will transform this by the formula. x2 value, x2 coordinate does not change in this formula, so we can just copy 100 to 100. And the first coordinate, x1 value is changed by half of x1 plus x2. So here, half of x1 plus x2, which is 150. Now, if we go back to the picture, then we will see that this corner is exactly 150 as the horizontal coordinate value and 100 for its vertical coordinate value. All right, now we take a look at its coding, its program. So it's Python code, and we can see that it's nothing but 6 lines Python coding. Of course, there's some preparation before that, like import the picture and import those Python packages, but the core part of the coding is just 6 lines, and the first 2 lines actually tells the computer what he needs to do. And if you look at these first 2 lines, the only thing you need to do is to tell the computer 2 by 2 matrix. The first row is 0.5 and 1. The second row of the matrix is 0 and 1. That's it. Then the computer will move all millions of pixels to a new picture. So why does it happen? Why this kind of transformation can be just equivalent to a matrix and you only need to tell the Python code this matrix? To learn this kind of application, learning Python programming part is easy, but to understand the mechanism behind this is hard part, and linear algebra does this job. So hopefully this can convince you linear algebra is a useful subject. Now we look at the next question. So the next question is about inverse transformation. So we have a point from new picture. Now we're going to identify its corresponding point in the first picture. This is very much related to real applications. So inverse transformation can be useful for face recognition. So you can use face recognition to pay your bill. You can unlock your cell phone, everything. So suppose there's some fraud detection, then what your bank does is inverse transformation and try to figure out the real identity from the fraud detection. So if you have fake face recognition, then you should identify the real identity behind this. So this is inverse transformation. So for this toy example, we took 1 point, 350, 300, which corresponds to this corner. And So we can see that 350 and 300. And now we want to know where it comes from the first picture. For this purpose, we first set the coordinate value of the pixel in the first picture as x1, x2, and then 350, 300 of the new coordinates should match the formula given by the transformation here. So this one is 350, this one is 300. And we have to solve it for x1, x2. And this is not hard problem, but this leads to our concept or definition of linear system and linear equations. So for this toy problem, it leads to a linear system of two linear equations, which can be explained in the next lecture. And I believe the solution is, if we solve that, I'm going to skip the detailed computation, but x2 is simply 300 and x1 is 100. If we go back to the original picture, so this was the coordinate, and we want inverse transform. It goes to 100, 300. So 100 and 300. All right, this is the end of this lecture, and after this lecture, I hope everybody understand what's the definition of matrix and vector, and I hope everybody is convinced to agree with the linear algebra is a useful subject. And thanks for watching.